Good morning. Today we are going to be concentrating on probability. My name is Kelvin. My contact details is +27778901449 My email address is mr.skchad@gmail.com. So here is what we are going to be focused on. So we are going to be focused on number one. We are going to concentrate on the definition and importance of probability. Then we are going to look at the key terminology in probability. We are going to concentrate on rules on probability. We are going to do the calculations, calculating probabilities. Then we are going to do types of events. Then some exercises. Then application of probability. How is probability applied in real life? Because we don't want to be learning things that we will say we are just learning for funny. We want to understand how are we going to apply this probability in real life. Then, so probability, as it is, you are saying probability quantifies how likely an event is to occur from impossible to certain outcomes. So in other words, when we are talking of probability, we are referring to chances of occurrence. We are just referring to chances of occurrence. When we are talking of probability, you just have to understand that we are referring to chances of occurrence of events. The chance that the event will occur or will not occur. So we have to know that probability will help us to predict future events by estimating the chance of various outcomes. So we'll be estimating whether the event will be occurring or will not occur. So that is one use of probability. Again, we live in a world where there's uncertainty, where we do not know what really happens. So we can use probability to manage uncertainty within the environments which we live in. Then let's move on. Now, our key terminology. Number one, we have to understand the terminology that we use when we are talking about probability. This is number one. We have to know what we call an experiment. An experiment is an action or process that leads to outcomes. For example, we can talk of tossing a coin. It's an experiment. Number two, we can talk of number two, another example of experiment, we can talk of even writing an exam. When you write an exam, it's an experiment which is having outcomes, which outcomes is either you are going to fail or you are going to pass. So you have to take note that. Number two, we have to take note of what we call an outcome. We have to take note of what we call an outcome. So number two, it's another definition that we have to know the result of a single performance of an experiment. For example, we said the experiment is tossing a coin. So, example of an outcome will be getting heads in a coin after we toss it. Or if you write an exam as your experiment, the outcome will be passing or the outcome will be failing. Then we have to know what's the sample space, another term that you are supposed to be knowing. Sample space is referring to all set of possible outcomes of an experiment, all set of possible outcomes of an experiment. If whatever experiment that you have done, the possible outcomes that will come out. For example, if we are to toss a coin in this case, what are the possible outcomes? It means we can get a head or we can get a tail. So the head and the tail is representing our sample space. And in the other example that we give of writing an exam, what is it that we expect to happen? It's either after you write an exam, you are going to pass or you are going to fail. So the passing and the failing, this is what are going to, the total of outcomes is what we are going to call, is what we call the sample space. Then what's an event? A subset of the sample space. So event, we are just referring to more of one or more outcomes. For example, if we toss Coin, getting a head, it's an event. Getting a tail, it's an event. So both, there are two events. If you check another example provided here, getting an even number when tossing a die is also an event. So these are some of the key terms that we are supposed to be knowing when we are dealing with probability. So those terms will help you a lot. Let's go to the next question, to the next section. We are now on the basic rules that we have to understand about probability. The basic rules that we have to understand about probability. Number one, probability range. Probability value is always a range between 0 and 1, inclusive, representing impossibility or certainty. So in other words, we are saying probability is, the probability can only range from 0 probability can only range from 0 less than or equal to probability less than or equal to 1, meaning to say probability can never be negative and probability can never be positive. If a probability is 0, it therefore means it's definite, it's certain that such an event will never happen. If we are told that the probability of this happening is 0, it definitely means that it's definitely that the event will never happen. If we are told that the probability is 1, it means the event is going to happen with certainty. It's 100% that the event is going to happen. So any values that are in between here, they will just express the degree to which the event will or will not happen. For instance, if the probability is 0.5, it means there is equal chance that the event will happen or the event will not happen. And we have to take note that probability can be given as decimals, that is from 0 to 1, or it can be given in percentages. If it's given in percentages, it means the range will be from 0%, not degrees. It will be from 0%. It will be from 0% less than the probability that an event, and less than or equal to 100%. And if it's given in percentage, 0%, it simply means that the event will not happen. It's certain that the event will not happen. And if the probability is 100%, it simply means that the event, it's certain that the event will happen. Then another thing that we have to understand under the rules, so number one, number two, the sum of outcomes, the probability of all possible outcomes in a sample space equal was to exactly 1. So if we add up the probabilities of all the possible outcomes that we could get, they are supposed to give you a 1. And then we are supposed to lastly know what we call the addition rule. The addition rule generally says probability of A union B must be equal to probability of A plus the probability of B minus the probability of A intersection B. We are going to define these. We are going to define these meanings. So union here, you might see it as or. Then this intersection, it must be written as and. So we are saying probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Then what we call mutually exclusive events, it means if we are told that events are mutually exclusive, probability of A union B must be equal to probability of A plus probability of B. Don't worry about these types of events. We are going to discuss them in detail. So the other thing that you are now supposed to take note here before we go further is the issue of notation. Is the issue of notation that you have to understand in probability. For example, if we want to say probability of event A, if we just want to say probability that A will happen, we just have to write that as probability of instead of writing the full statement that probability A will happen, we can just write that as probability of A. This statement it simply means probability of A. Right. Let's go to the next one. So you have to take note that all this what we are talking about is going to help us when we'll be solving problems academically and in real life scenarios. Then let's go to the next question, to the next slide. Now let's go. How do we calculate probability? How do we calculate probability? Having done what we said the basic, we said probability simply means chance, chance that things will happen or will not happen. So having explained what we just explained, let us now go to how do we calculate probabilities. Right. To calculate just a simple probability is the ratio of favorable outcomes to total possible outcomes. So we are saying this, if we are to write, remember, we said it's a ratio, and generally a ratio is a fraction. So they said it's a ratio of what? Favorable outcomes. So we are saying definition of simple probability. So we are saying probability of event to happen. For instance, event A will be equal to favorable outcomes divided by total of the possible outcomes. Total of possible outcomes. So let's put an example. Suppose we toss a coin. Suppose we toss a coin. Then you are asked to get the probability of getting a head. So if we toss a coin, what is it that you are going to get? It means you either get a head or you are going to get a tail. So what is the total number of possible outcomes? It's 2. So already here we said our denominator is representing the total number of outcomes. So it means our denominator will be 2. Then the question was saying the probability that if we toss a fair coin, we are going to get a head. So how many heads, favorable outcomes, how many heads are we going to get? It's only 1. It becomes our numerator there. So it therefore means that we are now going to have 1/2. Then we can give another second example. Let's give another second example before we move on. We are going to go to the questions. So another example, you can, let us say, probability. A family is made up of 3 females and 4 males. Then the question will ask, what is the, if we are to pick one person at random, if one person is picked at random, what is the probability that the person is male? So it means our answer is now going to be, using our formula, we said favorable outcomes. So our favorable outcomes, what is it that we want? What is it that we want? Let's go and check. What is it that we want? We want males. How many males are there? You are told there are 4 males. So these are the favorable ones. This is how many males can be chosen, the favorable ones. So it means is 4 divided by how many? It's saying 2. Total possible outcomes. Total possible outcomes. How many are there in total? How many people are there in the family in total? So it's going to be 4 plus the 3 females. It becomes the total, which becomes our denominator. So the probability of choosing a male in this family is going to be 4 divided by 7, like that. Then let's move. Let's move to the next. So here, calculating probability, these steps, we have already summarized this. This has already been done. How has it been done? Let's use another pen. How has it been done? When you are calculating probabilities, number one, you have to identify all the possible outcomes, because all the possible outcomes become our denominator. All the possible outcomes become our denominator. Then, 2, you have to determine the count favorable outcomes. You need to have favorable outcomes. The favorable outcomes become our numerator. So we say the probability from the previous slide, we say the probability that an event will happen will be equal to favorable outcomes divided by all outcomes. So the steps, we say identify all the possible outcomes because we need them for our denominator. Then also count all the favorable outcomes. We need them for our numerator. Then apply the probability formula. So this is the probability formula. We identified this, then we apply there. Okay. Let's move right. Here is one of our example, coin toss. So if you check here, we are talking about tossing a coin. Okay, each side of a fair coin, head or tail, has an equal probability of appearing when tossed. Then, so if we are to check, let's talk of tossing a coin. We have been using this example. So if a coin is tossed, how many total outcomes are there? As discussed in the right outcomes are there. Yeah, which was our number one. How many total outcomes are there when you toss a coin? There are 2. Here, there are 2, which is we can get a head or a tail. When a coin is tossed, it's either we are going to get a head or a tail. That's the total number of outcomes. Then the question is talking of how many favorable outcomes. So if they say for you to get a tail, so the probability is 50, percent. So if you are to get a tail, how many tails are you going to get? Because our denominator we said is 2, because we can only get a head or a tail. So what is the probability of getting a tail? How many tails do we get? It means it's going to be 1 tail divided by the total, a tail and a head. Okay, then let's go. If it was to get a head, probability of getting a head, how many total outcomes are we having? We are having 1 head or 1 tail. So our denominator is 2 there, which is the total outcomes. Then our numerator is what? Our numerator is going to be 1. How many heads do we expect? So this one, each coin toss is independent, so previous results do not affect future probabilities. So you have to take note of that. So let's try to do another example. Let's try to do another example. So if you roll a 4, chance of a 4, what is the chance that you get a 4? If we are to roll a die, what is the probability that you get a 4? As we said chance simply means probability. So don't be confused when you see them asking you questions of probability by saying chance. So here, what's the chance of getting a 4? So we are saying the probability. It's not clear here. The probability of getting a 4 will be equal to, when you roll a die, remember we said how many total outcomes are we going to get? A standard die is going to have 6 because it's cube. It's a cube. So it's going to have 6 faces. 1, 2, 3, 4, 5, 6. So it will be 6. Then how many 4s will be there on the die, on a standard die? So it will mean that we are having a 1. We are not going to write the 4. We are saying how many 4s will appear. So it's only 1. So the probability becomes 1 over 6, the probability of getting a 4. Now let's still go to that of rolling a die. Because the questions come in different forms. They can now ask you, if you roll a die, what is the probability that you get a multiple of 3? You get a multiple of 3. So it simply means that you have to know that probability, let us go and write it. So we want probability that you get a multiple of 3. So it's going to be probability. We are going to get a multiple of 3. But bear in mind, on a die, it's going to have 1, 2, 3, 4, 5, 6. So the total outcomes are 1, 2, 3, 4, 5, 6. So already it will mean that our denominator is going to be 6. So when we toss a die, so already here total outcomes is 6. Then multiples of 3. How many multiples of 3 are there? Let us list the multiples of 3. Let us list the multiples of 3. Multiples of 3. You will realize that we have 3, 6, 9, 12, and so on and so on. But we have to pick them from the symbol space. So our symbol space, we only have that 3. We only have another multiple, which is 3. How many are they? How many are they? Favorable outcomes. We see we have 2 favorable outcomes. So it will mean that the 2 becomes our numerator, because we say the probability is equal to favorable outcomes divided by total outcomes. So it means the probability that after rolling a die we are going to get a multiple of 3 is going to be 1 over 3. They can ask you the probability that after rolling a die, the probability that after rolling a die, we are going to get let me use that probability that we are going to get an odd number. Probability that we are going to get an odd number. So it's going to be equal to over total outcomes. What is the total of outcomes? We got them to be 1, 2, 3, 4, 5, 6. So already our denominator is going to be 6. What is, in this case, what is going to be our odd numbers? You have to understand what are odd numbers. What are odd numbers? Odd numbers, we are referring to those numbers that are not exactly divisible by 3. So can we list the set of odd numbers? Can we please list the set of odd numbers that we know? Odd numbers, it means we are going to have odd numbers. We are going to have 1, 3, 5, 7, 9, 11. So, how many? But take note, this is our sample space. We are not taking all odd numbers. From our sample space, which odd numbers are we getting? We are getting 1, we are getting 3, we are getting 5 there. So, it therefore means that the probability that when we roll a die, we are going to get an odd number is going to be 3, because the favorable outcomes is either a 1 or a 3 or a 5. These are the only odd numbers. So it's going to be 3 over 6. 3 representing the favorable outcomes, then 6 is the total outcome. So we are going to get, when you simplify that, it's 1 over 2. So we have to take note of that. Then let's go to the next example. Let's go to the next example. So, in our next example, still probability of picking a boy. So in this case, you are given identify. So there are 17 boys among 40 learners in a class. The question was saying there are 17 boys in a class of 40 learners. Then you were required to calculate the probability of picking a boy. So it means the probability of picking a boy will be equal to the probability of picking a boy. Here, probability of picking a boy will be equal to how many boys are in the class. Meaning to say, we can pick any boy from that number of boys in the class, but how many people are there in total where we are expected to pick only one person? We have 40 learners in a class, but how many of those 40 are boys? So this 40 is the total outcomes. This 40 is the total outcomes. Then how many are boys? 17. These 17 are the favorable outcomes, because we said we want to pick a boy. How many boys are there in total? There are 17, which means that we have got 17 favorable outcomes out of a total outcomes of how many, out of a total of how many learners in the class, out of a total of 40. So the probability of picking up a boy is going to be 17 over 40 there. So you have to take note that simple probability, we are just going to say favorable outcomes divided by total outcomes. Then let's go to different types of events. Number one, let's go to types of events. Number one, we are having independent events. We are having independent events. Two events are independent if the occurrence of one does not affect the probability of the other. For example, tossing two coins, the result of one toss does not influence the other. You'd realize that if we are to toss two coins, if I toss a coin, we are referring to fair coins. If I'm to toss a coin, whatever is going to happen, it simply means it's whatever is going to be happening on the first toss is not even going to affect the second toss. So those are independent events. But if the opposite of independent events, we have what we call dependent events, whereby the outcome of one event is going to affect the other. And in reality, we can talk of examples of, let's take, for example, reading could be one event. The second event will be either passing or failing. So you might realize that we might have a direct impact whereby the outcome of one event is going to affect the other event. So those types of events, we call them dependent events. But if the occurrence of one event or non-occurrence of the other does not affect the other, we call them independent events. What are the key properties of the independent events? What are the key properties of independent events? Number one, the multiplicative rule. If event A and B are independent, it therefore means the probability of A and B here. It means that the probability of A and B, remember here we said it can be written as and or A intersection B will be equal to probability of A times the probability of B. These meanings, we are going to dig deeper into them when we'll be talking about Venn diagrams and other things. So for independent events, we have to know that A and B, if they are independent, the probability of A and B will be equal to probability of A times the probability of B. Then you have to know that the aspect of complementary part. If A and B are independent, then it therefore means that A and B complement are independent. A complement and B are independent. Also, even A complement and B complement are independent. If we can just prove that A and B are independent, the happening of A and B are independent, it therefore means the non-happening of them or happening of the other, whilst the other is happening, they will also be independent. That's what it's saying here. So you have to know that if events are independent, that will also apply to their complements. Then that was type 1. We can go to the next type of events. Let's go. We have what we call mutually exclusive events. Mutually exclusive events. You have to know that these are events that cannot happen at the same time. Two events are mutually exclusive if they cannot happen at the same time. For instance, when rolling a single die, getting a 3 and getting a 5 are mutually exclusive events, since you cannot get both with a single toss. So mutually exclusive events, we are saying those events cannot happen at the same time. So what are the properties of mutually exclusive events? There are no overlaps. There is no intersection. So two events are mutually exclusive if they cannot both occur at the same time. The occurrence of one definitely excludes the possibility of the other. Since they cannot occur together, the probability of both A and B happening is 0. So Unlike independent events, we said the probability of A and B is equal to probability of A times probability of B for independent events. But when it comes to mutually exclusive events, you have to know that probability of A and B will be equal to 0. The probability of A and B will be equal to 0. Then the additive rule is now going to apply. It will affect the mutual exclusive events. For mutual exclusive events, it means now if two events A and B are said to be mutually exclusive, it therefore means that the probability of A or B will be equal to probability of A plus the probability of B will be equal to probability of A plus the probability of B. But we are going to discuss all these further then. Another type, we are now have on complementary events. The complement of an event, which we normally denoted by like E prime, consists of all outcomes in the sample space that are not in E. So for instance, we were talking of tossing a coin. If we toss a coin, the complement of getting a head will be getting a tail, because we said consists all things which are in the sample space but not in the other event. It therefore means they are the complement. For example, if E is rolling an even number, suppose you are rolling a die, then you roll an even number. If it therefore means the other event, which is E complement, is rolling an odd number, because we know that if we roll a die, which values are we going to get? Let's go. If we are to roll a die, we are going to get 1, 2, 3, 4, 5, 6. But if event E is rolling even number, so let's talk of even number. If event E is rolling even number, it means we are talking of 2, 4, 6. That will be event E. It will mean that event E complement will be rolling what is left, which is not even number. So we'd realize that it's going to be odd numbers. This is what is explained here. So complementary events, you have to understand that an event and its complement cannot occur simultaneously. So you have to understand that complementary events are mutually exclusive. Here, complementary events are mutually exclusive events. All complementary events are mutually exclusive events. Then, two, you have to know that they are exhaustive events. All complementary events are exhaustive events. What is it that we are saying by exhaustive? It means the probability. If we add the probabilities of complementary events, they must add up to 1. Because if we are saying exhaust from let's translation exhaust. So, and we said our probability, the maximum is 1. So if we exhaust, it means we have gone up to the maximum. So you have to know that complementary events are exhaustive events, meaning to say the probability of an event plus the probability of its complement must be equal to 1. So, together an event and its complement cover all possible outcomes in the sample space. That is, either E occurs or E complement occurs. There are no other possibilities. And as I already highlighted, since it's covering the entire sample space, it therefore means the probability The sum of the probabilities will add up to 1. Then the last part, the last type of events, let's go to the last type of events. The last type of events, we have exhaustive events. Events are exhaustive if together they include all possible outcomes of an experiment. Meaning to say, once events, they can make up the entire sample space. It therefore means that such events are exhaustive. For example, when tossing a coin, head and tail together form an exhaustive sort of events. It is worth noting that exhaustive events are not always complementary, while complementary events are always exhaustive. We have to take note that all complementary events are exhaustive, but not all exhaustive events are complementary. But we are going to look further on that property when we'll be doing more questions. Then properties, it covers all outcomes. It covers all outcomes. Exhaustive events by definition together account for every possible outcome of an experiment. No outcome in the sample space is left out. Each is included in at least one of the events. That is to say, the union of all exhaustive events covers the entire sample space. Then we have to take note that, as I highlighted earlier on, for exhaustive events may or may not be mutually exclusive or complementary. It's not always that exhaustive events are mutually exclusive or are complementary. They can be, but you have to take note on complementary, they are always exhaustive. But these exhaustives, they can be complementary or they cannot be. They can be mutually exclusive or they cannot be. On mutually exclusive events, also take note, mutually exclusive, it's not always that they are going to be exhaustive. But so exhaustive events do not have to be mutually exclusive or complementary. They might overlap or be more than two exhaustive events unless stated otherwise. However, if they are also mutually exclusive, each outcome belongs to only one event. Complementary events, by contrast, always form a pair, are mutually exclusive, and together are exhaustive. Then total probability is 1. Because exhaustive events encompass all possible outcomes, the sum of their probabilities is always equal to 1. So you have to take note of that. So as the name implies, exhaustive, so it means they must end up adding up to 1 in totality. In other words, we are saying exhaustive events form up the sample space. You have to take note that for complementary events, will be referring to only 2 events, strictly 2 events, but exhaustive events, they can be more than 2 events. Then let's go and check some typical exam questions. So we are given here, this question was extracted from the question paper, Department of Education, Department of Basic Education, November 2018, Mathematics paper 1, question 8.1. That was from grade 10. In a random physical science experiment, A and B are 2 different events. It was found that probability of A is that probability of B complement. You have to take note that it's B complement. If you check what is it that we are provided with probability of A, which is equal to 2 over 5. Then we are also provided with the probability of B complement, which is equal to 3 over 8. Then we are provided with the probability of A or B. which is equal to 5 over 7. Then the first question is saying calculate the probability of B. Take note, we explained about complementary events B and B complement, B and B complement. We said complementary events, they add up to 1. So it simply means probability of B plus the probability of B complement must be equal to 1. Then from there, we make probability of B the subject of the formula. So it means we transpose that one to that side. That is question 8.1.1. Transpose that one to that one. So it will be equal to 1 minus probability of B complement. Here is our B complement. It's 3 over 8. Then from there, since you are allowed to use your calculator, trust your calculator and go straight to using your calculator here. So it means this answer is going to be equal to 5 over 8 as illustrated there. 1 minus 3 over 8. Then the next question is talking of probability of A and B. But if you check from the information that we are provided, we are also given probability of A or B. And we said there's a formula for probability of A or B. Oh. Probability of A or B. Take note on the probability of A or B. We might have left that. The formula says probability of A plus probability of B minus probability of A and B. The one that we illustrated, we said if you are told the events are mutually exclusive, if you are told that the events are mutually exclusive, we said for mutually exclusive events, we said the probability of A or B will be equal to probability of A plus the probability of B. Why are we not showing that one? Remember, we said for mutually exclusive events, we said this part will be equal to 0. So it will be minus 0. That's why for mutually exclusive events, we are having that. But if the events are not mutually exclusive, if they do not cite anything about mutually exclusive events, it means this is the formula that you use. Probability of A or B must be equal to probability of A plus probability of B minus probability of A or B. So A and B, we are subtracting A and B. On the other side, you have A or B. Then now we have to substitute from what you have. The question wants you to calculate what A and B. So you are required to calculate this one. So substitute what we have. We are having probability of A or B, which is 5 over 7. We substitute 5 over 7 equal to probability of A is what? Probability of A is given as 2 over 5 plus the probability of B. What's the probability of B? We calculated it earlier on and we found it to be 5 over 8 minus the probability of A and B. This one is the one which is so, and it's having a negative. So how are you going to do that? So you can decide to take this. You can decide to take this one to the other side of the equal sign so that it becomes positive. Then you take this one which is there to this other side so that it becomes negative there. By so doing, it means you have made this probability the subject of the formula. So how is it going to be? Let's remove this. It will mean that we are now going to have probability, when it comes here, it was negative. Take note there, it was negative. So when it comes to this other side, we took it, the sign is going to change. It's going to be probability of A and B will be equal to this one. We are having 2 over 5 plus 5 over 8. Then when you take this one to that side, it was positive. When you transpose, it's going to be negative, to minus 5 over 7. And take note, since you are allowed to use the calculator, you have to take note. Since you are allowed to use the calculator, just use your calculator there. Just make sure you use your calculator here. When you use your calculator, you are going to get your answer of 87 over 280, which is what we got here. And I recommend leave your answer as a fraction unless the question strictly says leave it as a decimal. Then the last part is saying, hence determine whether A and B are mutually exclusive events. Motivate your answer. We agreed that for mutually exclusive events, we agreed that the probability of A and B is always equal to 0. But here you are given that after we did the calculation, we found the probability of A and B to be this value, which is not 0. Therefore, we can conclude that these are not mutually exclusive events. Why? Because the probability of A and B is not equal to 0. When answering these types of questions, don't forget to, in most cases, we make errors of leaving one part. Either you are just going to say not mutually exclusive, but forget to motivate your answer, forget to put your reason, or you just go and write the reason without answering the question of whether are they mutually exclusive. So take note, it's having two parts. The first part, you have to show, you have to answer, you have to side that are the events mutually exclusive or not. The second part, why are you giving your answer? As we did, the events are not mutually exclusive. Why? Because probability of A and B is not equal to 0. We have learned earlier on that if the events are mutually exclusive, it therefore means the probability of A and B is equal to 0. Then let's go to the next question. The next question is from Department of Basic Education, November 2017, Mathematics Paper 1, question 7.1, still grade 10. Two events A and B are complementary. So already, because you are told the events are complementary, what is it? You are supposed to bring what you already know about those types of events. You are told the events are complementary. So you have to bring what you already know about complementary events before you answer. So already we learned that if events are complementary, so it means the probability of A plus the probability of B plus the probability of B must be equal to 1, because you said if events are complementary, the sum of their probabilities must be equal to 1. And make up the entire sample space. So the fact that you are told they are complementary, it therefore means that they make up the entire space, the entire sample space. Even if this statement was not included, you have to know that complementary events, they make up the entire sample space. Also, you are now told that the probability of a complement, you are now being told that the probability of a complement is equal to 0.35. Then the first part is saying complete the statement. Probability of A plus probability of B. We already highlighted the probability of A plus probability of B must be equal to 1. Why? They are complementary events here. They are complementary events. And we said for complementary events, probability, the sum of their probabilities must be equal to 1. Then they are saying write down the value of probability of A and B. Write down the probability of A and B. We said that all complementary events are mutually exclusive events. All complementary events are mutually exclusive events. In other words, we are saying complementary events is a subset of mutually exclusive events. And we said for all mutually exclusive events, the probability of A and B is always equal to 0. So you have to know that probability of A and B is equal to 0. Then the last one is saying, write down the value of probability of B. Write down the probability of B. But you have to take note that A and B, A and B are complementary events. So it therefore means that the probability of B must be equal to probability of A complement. Must be, because we know that we say the probability of A plus probability of B is equal to 1. And the complement of A, we know it can be written as A complement. This must be equal to 1. So if you check, this is equal to 1, this is equal to 1. And both, if we are to make probability of B subject of the formula, taking, if we are to make the probability of B subject of the formula, it means we are going to take this one to this side. It means probability of B will be equal to probability of B will be equal to 1 minus probability of A. And here, if we are to take again A to that side, it will mean that probability of A complement is equal to 1 minus probability of A. And if we are to check this, and this, they are the same, they are equal. So we can conclude that probability of B is equal to the probability of A complement. And we have already established that we are already given that probability of A complement is 0.35. So it means probability of B will be equal to 0.35 there. Okay, then we go to the next. Is from December DBE November 2016 Mathematics Paper 1 question 8.2. Again, grade 10. You are told that a bag contains 3 blue balls and X yellow balls. Write down the total number of balls in the bag. So you are going to add the blue balls and the yellow balls. So it means the total number is going to be the 3 balls, 3 blue plus X yellow. Then you leave your answer like as that because we don't know the value of our X. So it would therefore mean that the total number of balls is going to be 3 plus X, which can be written as X plus 3 because it's more reasonable when you start with our symbolic expressions, when we start with our unknown. Then the next question is, if a ball is drawn from the bag, write down the probability that it is blue. So probability that it is blue. Remember we said always over total outcomes. Over all outcomes. All outcomes, how many balls are there altogether? We found them to be x plus 3. So it becomes our denominator. Then favorable outcomes. Favorable in terms of what? Blue. Because we want to pick a blue. How many blue are there? We go and check how many blue are there. 3. So the probability of picking a blue ball is going to be 3 over x plus 3, which is here. Then complete the following statement. If A and B are two mutually exclusive events, then probability of A and B, we said this many times, probability of A and B will be equal to 0. Then you are told, given that A and B are mutually exclusive events, the probability that A occurs is 0.55. The probability that B does not occur is 0.7. Calculate probability of A or B. So let's come here. The probability of B does not occur. It means it's the probability of B complement. That one, it means it's the probability of B complement. But we know probability of B complement, which is probability of B does not occur. B does not occur. It's the meaning of B complement. So it means we are now talking of complementary events. So the complement of this is what? So it's going to be plus the probability of B, meaning to say B will be equal to 1. So what is the probability of B? Probability of B will be equal to 1 minus B will not happen, which is 0.7. So it means probability of B is equal to 0.3. Once you get 0.3, you now come back here. You are told that the events are mutually exclusive. The events are mutually exclusive. So, and they want you to calculate this, A and B. So we know that for mutually exclusive events, we agreed that probability of A or B will be equal to probability of A plus the probability of B. What's the probability of A? It's given as 0.55. Plus, what's the probability of B? We just calculated it and we got 0.3. So as you can see here, our final answer is going to be 0.85. Then we go to the next question. Application of probability in real life. We are now on application of probability in real life. Application of probability in real life. You have to understand that probability is not something that we are only doing academically, which is not of great importance, which is not of use in real life. So number one, probability in games and sport. You'd realize that it is used for outcome analysis. Probability aids in analyzing the possible outcomes of games and sports event to guide decision making. It was also used still under games and sport for strategic influence. It is used, understanding probability helps players and coaches to develop better strategies to improve their chances of winning. Then, lastly, you know that we can use probability for forecasting results. Probability is being used for forecasting results. That's when you hear people saying, last time, how was the performance and what? So the chances, the moment you are talking of chance of, just know that is probability. So we use it to forecast the outcomes of games, whatever type of game that you think of. Then, apart from sport, it is used in weather forecasting and insurance. So probability in weather forecasting, meteorologists apply probability models to predict the likelihood of weather events accurately. Then in risk, because in every business, there are risks associated with doing it. For you not to run a loss, you need to understand. So you need to predict. You predict using what? Probabilities of events happening, probability for those who are doing economics, you know that, probability that the prices are going to fall. But remember, you'll be using some historic data, but you apply the concept of probability for you to come up with the those decisions. You can use probability for decision making. You have to understand that the world is always uncertain. It's always uncertain. We talk of scarcity of things, scarcity of resources. So since the world is uncertain, therefore we need to apply probabilities whenever we'll be making our decision. Probability helps individual assess different options when outcomes are uncertain, thereby improving the accuracy. When you want to invest, you use probability. Oh, if I invest here, what is the probability that I'll get back my money, and so on and so on. It is used in healthcare. So you have to take note that probability is something which is very important, very, very important. So, having done this, you have to understand that probability provides a framework for measuring and describing uncertainty in various situations, enabling informed decisions. So don't be fooled by people who will be telling you that, why are you doing maths? You will not use it. You see, we are talking of probability, and you are going to be applying it in real world. You are going to use it to analyze events. You are going it, for a lot of things that you are going to be doing, you need to understand, you need some background of probability. So you have to know that uncertainty is not a threat, but a source of opportunity. Embracing it can reveal unexpected chances for success. So take note that wherever you are going in the world, you are going to be applying probability. So you need to have some appreciation of the probability concepts. So thank you very much. Have a great day.